Jai Shri Gurudev. Today we are going to discuss about the extraction of iron from oxide ore. So as we know that in ore there will be a consisting of a lot of impurities, isn't it right? So we have to remove the impurities and we have to convert that ore into a particular metal. So we are going to convert the iron oxide, iron ore, that we are going to convert it into a iron form. So we know that the iron ore is there will be a hematite. So there will be, we are going to choose the ore that is nothing but the hematite ore, and we are going to use one of the procedure with the help of the diagram, that is nothing but the blast furnaces method. So in the blast furnaces method we are going to convert the iron oxide into a iron. So in this diagram, as we go for the diagram, there will be this may be a long furnace. So this is nothing but the long furnace is consisting about the 30 or 25 to 30 meter in height. So there will be different zones are there. There will be 4 types of zones are there in that temperature, based on the temperature. At the topper region, what happened, there will be a temperature is very low. After that there will be a going at the bottom region, there will be a temperature is undergo for the increasing. So remember, so the upper region the temperature will be a light low, and at the bottom region the temperature will be a very high. This is nothing but the construction, and there will be a topper region is there, that will be connected to a topper region, this is connected to a funnel. So at the beginning, so this is nothing that the bottom region, and there will be a, this is nothing but the setup of the blast furnaces. So the blast furnaces is used for the extraction of the iron. So with the help of the oxide ore, there will be a lot of impurities are there in oxide ore. That impurities we are going to remove and convert that oxide ore into a pure form of iron. So iron is very essential to our daily life, so we are depend upon the iron. So for iron is necessary, so we are going to purify the iron ore, so in the form of the purified form of the ore. So firstly we have to take iron ore. What the iron ore is there, we have to take that iron ore. So along with the ore we are going to add the limestone. As we know that what is the limestone, we studied in the previous class. Along with the coke we are going to take. So this is nothing but the powdered form. Now we are going to take a ore and the limestone and the coke in the ratio of, this is in the percent of the 12%, and the limestone in the form of the 3%, and the coke in the form of the 5%. So 12 is to 3 is to 5. This is the ratio we are going to take for beginningly, and we have to finely powder the ore. So that hematite ore along with the limestone, so along with the coke, these are the impurities which are present in a iron ore. I have selected this and the powder form, I have inserted it with the topper agent to this particular furnace. So we have to take first the powder ore and I have to insert this into a blast furnaces. What happened at the beginning? When you go for the add of the impurities, they come and collect at the bottom region. What happened? They suddenly come and falls at the bottom region. So in the, as we know that there will be a hot air we are going to pass this particular blast furnaces, and we go to heat. So hot air, and also we are going to apply for this. There will be a furnace in the sense that is a heating procedure. So we are going to, by applying a heat, we are going to heat with the help of the hot air. So we are supplying a blast of the air into this particular region. So here the opening are there. This opening are made us to help to pass the air to this chamber. So at the beginning stage what happens, so and after there will be a what happen, we are going to study the first state or the first zone is nothing but the combined zone. So what happened in the combined zone? So after this is nothing but the combined zone. In the combined zone, after we are adding this the composition into the blast furnaces, there will be a heating or there will be a heating will be takes place. When the heating will be takes place, reaction will be takes place, as I explained in the before. At the heating what happened, I told that there will be this is the mixture. So what the carbon impurities are there, what the coke is there, or the limestone, there will be a, so what the carbon is there, so it is combined with the oxygen. Remember we are passing a hot air, so in the oxygenic form. So this coke, this react with this coke is react with the oxygen, it lead to the formation of carbon dioxide. And there will be this another, if there will be having a carbon dioxide as the impurities in the ore, that is combined with the carbon, it lead to the formation of the carbon monoxide. So there will be a formation of carbon dioxide, and the carbon monoxide will be takes place in the combustion zone at the temperature range is 1773 Kelvin to 1873 Kelvin. The zone of combustion will be takes place. at that time, so there will be a reaction, will be actual reaction will be takes place, the combustion is takes place here, and in the sense the when you are going to apply the heat and temperature, so what happen, there will be a combustion will be takes place, reaction will be takes place. What are the unwanted gases, carbon dioxide or carbon monoxide, they come slowly comes to the upper surface, then they escape here, exhausting gas. Look at here, exhausted gas, they consisting of the carbon monoxide and the carbon dioxide. These are the impurities which are present in a iron ore. ಐರನ್ ಓರಿನಲ್ಲಿ ಇರುವಂಥ ಇಂಪ್ಯೂರಿಟೀಸ್ಗಳನ್ನ ನಾವು ತೆಗಿಬೇಕು ಅಂತ ಹೇಳಿದರೆ ನಾನೇನು ಮಾಡ್ತಾ ಹೋಗ್ತೀನಿ, ಆ್ಯಂಡ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಆ್ಯಡ್ ದ what are the impurities is there or what are the ore is there, that composition I am going to add at the topper region, they come and collect at the bottom. When you apply the heat and temperature, what happen, the reaction will be takes place. When the reaction will be takes place, what happen, the extraction, the exhaust, or there will be a liberation of the impurities in the form of the carbon dioxide and carbon monoxide. So this reaction takes place actually here and they liberated and escape at the topper region. So this is nothing but the combustion of region. So this is nothing but the combustion zone. So now we are moving to the second zone, that is nothing but the reduction zone. So reduction zone is nothing but the reduction process. How the reduction will be takes place, that is nothing but the reduction zone. So after removing of the impurities or the carbon dioxide or carbon monoxide, what are the impurities are there, the ore consisting of a iron hematite, which is in the form of the Fe2O3, also in the form of the Fe2O4. So the maybe the ore consisting of the oxygen as the impurities in the Fe2O3, the ore consisting of oxygen in the form of the Fe along with the oxygen, the ore consisting of Fe along with the FeO4 of the oxygen. These are the ore consisting of the oxides. So different ore consisting of the oxides. So firstly, Fe2O3 is react with the carbon monoxide, it will lead to the formation of the iron. So I will get about the remove of the carbon dioxide as the impurity. So I will get about the iron. Suppose if the ore consisting of the Fe2O3, iron oxide in the form of this one, otherwise the iron in the form of the Fe2O, what happens in that particular place, if I go with the treat with the carbon monoxide, what happens, that carbon oxide is converted into a iron. So here also I get about the iron. So next there will be a what the Fe3O4. So suppose the iron ore consisting of oxide in the form of Fe2O4, in that particular case we are going to reduce with the 4 molecules of carbon dioxide. Here also the formation of the iron will be takes place. So in the reduction process, the removal of oxygen will be takes place. So as we clearly understood with the Elegam diagram also, this carbon monoxide is a good reducing agent for the hydrogen based on the temperature and gives free energy. So this explain about the reduction zone. So the reduction process will be takes place at the bottom region. So what happened in this case, so this is nothing but the zone of, here I told that zone of combustion will be takes place in the range of 1773 to 1873, and after that reduction there will be a 673 Kelvin to 973 Kelvin. So maybe the reaction will be takes place here, reduction will be takes place here. So what happened in this case, if the iron ore consisting of the different composition of oxygen, it will be treated with the carbon monoxide, so there will be a reduction process will be takes place. So this reduction, we are using a best reducing agent is the carbon monoxide. With the help of the best reducing agent, we are going to remove the oxygen and we convert that particular ore into a oxide form of metal into a ore. This is nothing but the reduction zone. This is the second zone. Nextly, we are moving with the next is nothing but the slag zone. So slag zone is lies in the middle. So slag zone is lies in the middle. What is this slag zone? So I told that in the beginning I am going to add the limestone. So limestone ore, if we take ore and we also take a coke. So the coke step will be explained by the combustion zone and the ore will be explained with the this one. In this what is that, reduction of zone. Ore in the sense this may be the ore, this may be the ore, this may be the ore. So the ore will be takes place and the remaining is limestone. So the zone of slag formation. So in the slag formation, what happens, this limestone, what we select the limestone in the form limestone, CaCO3, calcium carbonate, has we all know that limestone, the formula is nothing but the CaCO3. When the CaCO3 is considered as the flux, we are going to consider here as the flux. That flux undergo decomposition reaction. When you apply the heat, what happens, the decomposition reaction will be takes place. When the decomposition of reaction will be takes place, what happens, this calcium carbonate is converted into a calcium oxide and carbon dioxide. This is the decomposition reaction when you apply the heat and temperature. When you go for the rising heat, there will be temperature increases, automatically the calcium carbonate suddenly start to decompose and convert the calcium oxide and carbon dioxide. So this is nothing but the flux is undergo. This is also considered as the flux formation, calcium oxide. When the flux, what the calcium oxide is there, that is react with the impurities which is present in ore. So gangue irbodu, impurities irbodu, namge gottu gangue is also called as the slough. So gangue is also called as the impurities. So we are going to add the silicon dioxide as the gangue which is present in the ore. So nama iron ore nalli iruvanta impurities. So this is nothing but the impurities is mixed with the flux. There will be a formation of the slag. What is slag? May they ask for the 1 marks question. Slag is nothing but the when the flux is react with the gangue, it lead to the formation of the slag. What happen? It lead to the formation of the slag. So this is nothing but the zone of slag formation or slag zone anta heluvanthadu. So this is nothing but this reaction will be takes place at the 1073 Kelvin to 1273 Kelvin. So this is nothing but the slag zone. What we call this is nothing but the slag zone. At the beginning, what happened? There will be a combustion will be takes place. At the combustion, carbon monoxide or the what the coke is there, this coke is combined with the oxygen, supplying oxygen, that will be liberate the carbon dioxide. If that carbon dioxide is combined with the coke, in case it lead to the formation of carbon monoxide, they are the exhausted or they are the unwanted gas, they will be released at the topper region. So in the reduction zone, what happened? There will be what are the different types of ore are there, that is reduced with the best reducing agent carbon monoxide. So there will be what is the role of the reducing agent to that, to remove the oxygen which are present along with the ore, we are going to remove and we convert that into a iron, and that is nothing but the iron form. In the slag zone, what happens? We have a slag, that is nothing but the calcium carbonate, sorry, we have a flux, that is nothing but the calcium carbonate, that will undergo decomposition reaction when you apply high temperature of heat, that converted into calcium oxide. So that calcium oxide is treated with the gangue, it lead to the formation of the slag, hence that zone is also called as the slag zone. This is nothing but the temperature zone. So next is nothing but the fusion zone. So what happened in the case of the fusion zone? Here you come about the, so after that there will be a liberation of gas will be takes place, there will be a slag formation will be takes place. After that there will be a iron. So what we get, what the iron? So what the iron we get, they are in the two form, molten slag and there will be a molten iron. So what the iron we get, that iron in the form, so here I get the slag, right? So that is nothing but the, we are going the molten slag. So molten in the state, that will be in a liquid state with the high boiling point, with the boiling state. So molten slag in the state, the slag which is present there in the zone of slag, that slag come and collect here along with the slag, there will be a molten iron. So there will be, I told that there is a slag is there along with the iron oxide is also is there. So if you go for the iron oxide is also there, iron is oxide is also there. So there will be in a molten state. Why they are in a molten state? By increasing the temperature, they are in the form of the liquid state with the boiling point. So there will be in the form of the liquid state. So we have a slag, that is in the form of the molten state or in the form of the liquid state, and also we have a molten iron in the state we go in that, there will be, we have a iron. So these are the two type of the molten states of the solution are there. So here why the molten slag will be in the upper surface, why the molten iron will be in the lower surface, means this molten slag, what the slag we get here, that molten slag is lower in weight, so they are lighter in weight, so they collected at the topper region, and this is nothing but immiscible liquid. You know about the difference between the miscible and immiscible in the first PUC class. So this is the immiscible in nature. So these two layers are separated, are fused, and they are separated by this two layers are there. So they are present at one another, they are in the fusion form. So this is nothing but the fusion zone. Why this zone is called as the fusion zone? In the sense, the zone which is consisting of the molten slag as well as the molten iron. So this is nothing but the zone of fusion or fusion zone we called as. So there will be this in the lighter in weight, so it will be lies in the above, it is a higher in weight. So there will be iron is there, so either iron is higher in weight, so they are collected at the bottom. So it is in a liquid state. So while there will be immiscible liquid, there will be having one thin layer is there. With the help of that, we are going to collect with the help of the solid waste, that is nothing but the molten iron. After cooling this way, after cooling this, get converted into a solid, and there will be a solid waste we are going to collect at the topper region. Next we have a molten iron. What we have a molten iron. What is molten iron? The molten iron, what happened in this case? So there will be in a liquid form. So we are going to decrease the temperature at a particular range. What happens? There will be this molten iron is converted into a solid form of iron, that is with the help of the furnace is called as the pig. So that is nothing that type of iron. So it is nothing but the pig iron. When the molten iron is cooled in a furnace, the particular area with the help of the particular region, that is nothing but the pig region. So that iron is called as the pig iron. What is pig iron? The solidified form of the molten iron in the blast furnaces. So that is nothing but the pig iron. So the pig iron is not a pure form of iron. So this will be consisting of a highly impurities. So what happened in this? There will be a consisting of the highly impurities, and also it consisting of a 4% of carbon has the impurities. How many percent of impurities are there? 4% of carbon impurities are also present. Pig iron is also described as the pig iron is nothing but there will be this pig iron consisting of a 4% of the impurities is there. This is in a brittle, this is very hard, we cannot give a shape, it is not as soft in nature, so it cannot be used for our daily life or the commercial purpose. So this is not a pure form. How many percent of impurities, carbon impurities are there? 4% of carbon impurities are there in a pig iron. So what the pig iron I get? So I get about the pig iron. This is consisting of the 4% impurities. So this pig iron can be converted into a cast iron. So I converted into a cast iron. So there will be a what is this cast iron? This is also this pig iron is also converted into a cast iron. The cast iron is nothing but there will be having a less amount of impurities, or there will be a consisting of the 3% of impurities are present. There will be a lesser in the impurities, they may be a more useful. So isn't it right? So what the pig iron I get there? So the pig iron in the the molten iron is solidified. That solidified iron consisting of that solidified iron is also called as the pig iron. That pig iron is converted into a cast iron by converting that solid into a liquid form. Now we get about the what the iron form we get is nothing but the cast iron. That cast iron is the 3% of carbon as the impurity. So that is not a purest form, but we get about the cast iron here. So this cast iron, what we get the cast iron is not a pure form. This is also a harder in to touch, and also there will be cannot be used for the commercial purpose also. Next, what the iron we get, what the cast iron we get, that iron we are going to convert it into a rough iron. So rough iron in the sense that is a purified form of the iron. So what are the impurities are there? Maybe the sulfur impurities is there, maybe the manganese impurities are there, maybe the phosphorus impurities are there in this particular cast iron. That iron is react with the reducing agent or our convenient, or with that particular reducing with the help of the reducing agent, we are going to convert that what the cast iron consisting of the 3% of impurities, we are going to convert that ore into a pure form, that is nothing but the rough iron. The conversion of the cast iron into a rough ore, so that is nothing but the pudding. We also called as the pudding. What is pudding in the sense we are? So here I get about the what the cast iron is there, which is consisting of the 3% of impurities, that is converted into a rough iron. The process of conversion of the cast iron into a rough iron, that is nothing but the pudding. So the that is called as the pudding. So what the iron there will be a consisting in the rough iron, that is nothing but the very 0.05 to 0.2% of impurities are there, very soft in nature that particular iron, and we can use for the commercial purpose. And also what we are going to see daily life in a iron, that is nothing but the rough iron. So now we explain about the molten slag and the molten iron. So the molten iron is converted into a pig iron. That pig iron nothing but the solidified form in the form of the 4% of the carbon as the impurities. What the solid form of pig iron is there, again we are going to melt that one, it is converted into a cast iron, so liberating the impurities. So liberation of carbon will be takes place, 3% of impurities it is present. This impurities also can be converted into a pure form, that is nothing but the pudding. That process is called as the pudding. So that is nothing but the rough iron.